Hello, this is John from caveofprogramming.com. In this video we're going to take a look at getters in Kotlin. Let's create a class up here. So we'll have a class, I'll call this financial instrument, and this is supposed to represent like a stock or a share or something. Let's say that this has let's make it an immutable property called code, and that's going to be of type string. So now when we create a financial instrument, we can set that value. In fact, we have to. So let's write val, I'll just call it fi, equals financial instrument. And when we create an object like this from this financial instrument class, we have to pass the code to it. So let's say we've got some share in some company or something, and it has the code ABCDE. Once we've initialized this property, because it's immutable in this particular case, we can't then set it again, but we can access it. We can do print line and fi dot code. Let's check that this works. So we get ABCDE. Now in Java and in many object-oriented programming languages, this would be something that you shouldn't do. You shouldn't access the values of properties directly like this. In Kotlin, that's by no means necessarily the case. In fact, this would be the recommended way to access this code property. It is often the case that you want properties that are only used internally within the class, and there are ways that we can restrict access to those, which we'll look at later. But let's imagine that this isn't one of those. This is something we're happy with people accessing externally outside the class like this, so we want them to be able to do this. Now let's imagine that we've got another property here. Let's say val name, that can be of type string, and what we want to do is just set name to the code but in uppercase. So maybe we could write equals code dot uppercase, and then we ought to be able to print fi dot name, and that works. So if we run it, here we get ABCDE in uppercase. But then what if we change our mind about the possibility of being able to update code here? So what if we change it to a var, and then after we've already printed them, let's say fi.code equals something else like zyxwv, and then we try to print the name again. In fact, let's make that lowercase, zyxwv. So when we run it now, what we find is that name is still set to ABCDE, because we only actually initialize name when we first create the financial instrument right here. What we'd really ideally like is that if you update code like this, name will also get updated. And one way we could handle that would be with a thing called a getter. So a getter or get method is a function, or better said a method, which will run every time you try to access the value of a property, and what you'll actually get will be the return value of the getter. So I'm going to go to the next line here, and I'll use the tab key to create an indent, and we'll write get, and this is actually going to be a function, so we could implement it using curly brackets, but if I just want to return a single value, I could use the expression function style of implementing it, which we've seen previously. And I can just write an equals sign here, and after that, the expression that I want to return. And remember, an expression is just something that evaluates to a single value. So what do I want to return? Well, code dot uppercase. And now Kotlin actually complains, and what it says is initializer is not allowed here because this property has no backing field, and we'll look at backing fields shortly, but let's get rid of this for now to make it happy. And now let's see what happens. So when I run the code, after we change the code to zyxwv, if we then access name, we get uppercase zyxwv, exactly as we want. And that's because when we try to get the value of name now, this function will actually be run, and that returns code.uppercase. Now sometimes you actually want to refer to the current value of the property itself within the getter. So let's change this to a normal kind of style of function. So I'm going to use curly brackets here. That can go on the next line here. We've got a closing curly bracket there. And here we want to do return code.uppercase. So far that's going to work exactly as it did before. If we run it, we see that we get ZYXWV here. So you can perfectly well implement this with a more typical style of function. Now let's imagine that for some reason you decide that you want to refer to the existing value of name within this function. So as an example of that, a stupid example but hopefully illustrative, let's put in print line name. Now you notice that I get this circular icon here, and what it's telling me is that I've got a circularity in my code. So when I try to access the value of name within the get method itself, that will actually invoke the get method. Just the same as if I try to access it externally like I do here. This invokes the get method, but so does this. And the trouble is it's already within the get method. So now I've got circularity going on. I've got unwanted recursion. So this calls the get method, which runs this, which runs the get method again, and so on. So if I actually try to run this, what I'm going to get is a really long stack trace where it's trying to call get over and over and over again. And eventually it just gets tired of it and it says enough is enough and it stops. And the error is actually a stack overflow error, the notorious stack overflow error, where you have infinite recursion. Recursion is just where a function calls itself. And that can be okay if you have a mechanism for stopping the recursion. But in this case, it's entirely unwanted. We don't want this to happen at all here. And for that reason, Kotlin provides you with something called the backing field. The backing field is basically a copy of the value of this property that's kept in memory so you can access it within getters and setters. And we'll look at setters in the next video. The name of the backing field is just field. And when I run this now it tells me the property must be initialized. So when I try to do this, Kotlin says, okay, now we need a backing field. But if you have a backing field, you've got to initialize the property. So now I would have to write, for example, code.uppercase. And now it all works. So if I run it, you can see that we're actually printing the current value of field. Let's make it a little bit clearer by writing field value : and I'll output this via the $ syntax. And when we run that, here it's saying field value is ABCDE. In fact, by doing this, we're not actually changing this value at all. We're simply changing what we return. We can't even change name as it stands because it is a immutable value. We didn't use var here, we used val. So we'll look at this a bit more in the next video. But for now, let's just get rid of that. And then once we get rid of it, Kotlin says, okay, this doesn't need a backing field, so I'm not going to create one. And that means you don't need to initialize it. And then we get back to this. Okay, so that's it for this video. This is a little bit complicated, but if you just practice it, it's really not that hard. The bottom line is just that you can supply a get method like this. And when you try to obtain the value of this property now, what you'll actually get will be the return value of this get method, which can also be a expression function style method. And if you need to access the value of the property within the get method itself, you need to just use the field value instead to prevent recursion. So until next time, happy coding.